about not knowing Coulomb's law. Lots of people are struggling with Coulomb's law, okay? So Coulomb's law says that yes, there is an attraction between the positive and negative charges. We all know this. Opposite charges attract. We know this. But what Coulomb's law says is that this can be changed. This can be affected. And there's two factors this can be affected by. The first factor, let's just make a new one. The first factor that can affect Coulomb's law, and I think most people have this, is distance. So first factor, distance. The first factor that affects these positive and negatively charged charges from attracting is distance. So if we think about magnets, right? Oppositely charged magnets, they attract. But they only attract within a certain distance, right? Just when you get them farther and farther apart, right, so these are going to attract each other because they're oppositely charged. If we get them farther apart from each other, and I really didn't mean to make them bigger, but there I did, so blah. So if I get them farther apart from each other, what happens? You don't feel their attraction so much. So the first factor that affects Coulomb's law is distance. So more distance less attraction. And that should be attraction. All right, so the farther and farther apart we get these particles, the less they're going to attract each other. So what does that mean for the periodic table? Because we got to be able to apply that to the trends. So where we see more and more distance is down. Whoa, okay, let's get back to pen. There we go. Back that up. Okay. Okay, so where we see, my life is not going right here. So where we see more distance come into play is down a group. Because down a group, the electrons are being filled in different energy levels, and different energy levels are moving farther and farther away from the nucleus. So if we drew this, if we drew lithium, it would have two energy levels and then electrons filled in there, right? And then sodium would have three energy levels, and then potassium has four energy levels. And you see that inside the nucleus here is getting farther and farther than from the charges that it's attracting. So farther distance, more distance, less attraction. So that means that the nucleus has less hold on the electrons that it's keeping circulating around the atom. So we're talking about the attractions from the protons in the nucleus and the electrons outside the nucleus. That's the attraction we're talking about in the atom. It's a Coulombic attraction. It's positive and negative, but it changes what happens. So the trends are patterns in the periodic tables that atoms have, and that is changed by Coulomb's law. It's affected by Coulomb's law. So Coulomb's law is the reason behind every trend in the periodic table. So the trend for atomic radius is increasing down a group. That's because there's more distance. Okay? So what other trend that affects down a group, because down a group is the distance, is ionization energy. So down a group, atomic radius increases. So the size of the atom gets bigger. That's what atomic radius is. The size of the atom gets bigger. So atomic radius increases down a group. Ionization energy decreases down a group. And so what that means is that it's easier to pull an electron away. That's what ionization energy is. It's the energy to pull an electron away. Well, more distance, less traction means that the nucleus doesn't have as hard a hold on the electron. So yeah, it's easier to pull an electron away, right? And electronegativity also decreases down the group because more distance, because the electrons are not as attracted to the nucleus. And electronegativity is how much pull the nucleus has on other electrons, not its own, other electrons that it bonds with. So if it doesn't have a hard hold on its electrons, it can't pull anybody else's electrons. So all of these trends are due to this more distance, less attraction. And most people have a pretty good handle on that. Now, let's talk about the second thing that affects Coulombic attraction. So we all know, plus we're talking about oppositely charged particles. Hello, give me a pen. Give me a pen, thank you. All right, so we're Coulomb's law, oppositely, my life. Okay, hello, thank you. Oppositely charged particles attract. I'm not saying anything against that, but the two factors, the first one's distance. The second factor is charges. So when we talk about increasing charges, we're talking about adding more protons and adding more electrons. So we can see that as charges increase, what would happen to the attraction? Attraction increases. Okay, so the attraction between these two particles right here is not going to be as much as the particles right here. So more charges, more attraction. So the two factors are less or more distance, less attraction, and more charges, more attraction. So let's go look in the periodic table and see what that affects. Because it affects our trends, but it does not affect our trends going down a group. It affects our trends going across a period. So let's see how more charges, more force affects it. So if I drew lithium here, I have 2 electrons in its first energy level, and I have 1 electron in its outer level. All right, so 3 protons, right? 3 protons, 3 electrons. Okay, now let's look at nitrogen here. Well, it's got the first energy level with 2 electrons, and it's got another energy level, so it's got the same amount of energy levels as lithium. So the problem is not distance. That's not what's affecting Coulomb's law. What's affecting Coulomb's law is that it's got 7 protons and 7 electrons. So it's got more charge. So lithium has 3 protons, 3 electrons, so that's just 6 particles attracting each other. But nitrogen over here has 14 particles attracting each other. So more charges, more attraction. Okay, great. What does that affect? Because that's what we're looking at. What does that affect? So see how I drew these? Lithium's bigger. Lithium is a bigger atom. So we talk about atomic size. That's one of our trends, atomic size. It's one of the patterns in periodic table. Atomic size across a period decreases. So you remember in our last atomic size, when we went down the group, it increased because distance, right? Well, here we have increasing attraction across a period, so it decreases. Atomic radius, atomic size, same thing, decreases as we go across a period because more charges, more force, more attraction. So the nucleus has a tighter hold on its electrons, and it can pull those electrons in. That is what happens and makes it smaller. So that's how more charges, more force affects going across the. Now, what else does it affect? What are the other trends? The other trend is ionization energy. So ionization energy increases. So atomic radius decreased going across in the period. Ionization energy increases, electronegativity increases. So ionization energy is how much energy it takes to pull an electron away. And if the nucleus has more hold on the electrons, it's holding them tighter, it's harder to pull an electron away. So that's why ionization energy increases across the period. Electronegativity increases because if you want to say it this way, the effective nuclear charges increase. So the effective nuclear charge increases because you have more charges, more attraction. So here in this group, the effective nuclear charge is 1. In this group, the effective nuclear charge is 5 because more particles, more force. So the nucleus has a tighter hold. It has more effect on the electrons than it does on the other end because more charges, more force. Okay, so 2 things that affect Coulomb's law: distance, more distance, less force, and more charges, more attraction. Okay, I'm going to end this, and then you can ask me questions.